Today we are going to discuss the title on pavement types and its components. Generally, pavement refer to the layered structure constructed over prepared soil to withstand the repeated movement of vehicles. These layers work together to distribute wheel loads safely to the underlying soils. Pavements must remain strong, stable and durable over their entire service of life. The primary types of pavements are used in the highway constructions. It may be a flexible or rigid pavements. Flexible pavements consist of multiple layers such as surface and then second phase and then subphase, typically using bituminous of materials. Rigid pavements uses cement concrete and usually rest on the base surface. Here next one is the functions and the requirement of pavements. A pavement must serve the primary functions of withstanding the loads from the traffic while providing a smooth driving surface, and then it should effectively distribute traffic loads through its layer to the foundation soil and resist deformation even under repeated loads. The pavement must also be durable, requiring minimal maintenance while withstanding various environmental and loading conditions. And then to fulfill its function, a pavement must meet several essential requirements, and also it must be structurally strong enough to handle the traffic induced stresses. The pavement thickness should be sufficient to distribute load properly, and then the surface must be hard wearing to withstand abrasion from moving vehicles. Then laterally adequate friction is required to prevent skidding. These materials used should be resist to water damage, and both initial and long-term maintenance cost must be remain economical viable. Here this one is types of pavement. The first one is a flexible pavement and then rigid pavements. The flexible pavement, which relies on bituminous bound layers for strength and load distribution, from the rigid pavement, which primarily uses cement concrete and behave a single structural slab. Each type has its own construction techniques, materials and performance characteristics. Here this one is a flexible pavement and this one is a cross section of the pavement. In the flexible pavement are constructed using multiple layers made from aggregate and bitumen. These material are heated, mixed, laid on a granular base and compacted. The structure is flexible with a low flexural strength, and load distribution occur gradually through each layer. The efficiency of each layer is transmitting load depend on the material used and the quality of the mixed proportions. Here the cross section of the pavement, first layer is compacted subgrade. The size is 150 to 300 mm, and the sub-base course and then 100 to 300 mm size, and the base course 100 to 300 mm size, and the binder course the size of is 50 to 100 mm. Last surface course 25 to 50 mm were constructed. Additionally, prime coat, seal coat, tag coat were used. And then rigid pavement. In the rigid pavement are made from Portland cement concrete and are often referred to a conventional cement pavement. They include transfer and a longitudinal joint that prevent and movement of soil slurry and reducing cracking. This pavement offer high flexural strength, allowing them to bridge minor irregularities in the base of subgrade. Unlike flexible pavements, rigid one distribute load over a wider area and are also affected by thermal stresses due to temperature variations. This slide represents the comparison of flexible pavement and rigid pavement. The first one is in the flexible pavement, it is a multiple layer, and in rigid pavement it consists of mainly of cement concrete slab with a flexural strength. I already shared in the rigid pavement topic. And the flexible pavement design procedure are mainly empirical, but in the rigid pavement design procedure are more precise. But in the flexible pavement it reflects the deformation of subgrade sub-base, base courses and the surface, but in the rigid pavement it can bridge over local weak spot and deformation without reflecting them on the surfaces. Okay, here in the flexible pavement depend on subgrade strength for their performance, but in the rigid pavements depend on the flexural strength of the concrete slab. Okay, but in the fifth point, the transmission of the stresses for in the flexible pavement to the subgrade is throughout the component courses, but in the rigid pavement distribution of load to wider area of the subgrade depend on the rigidity. Okay, and also the flexible pavement stability depend upon interlocking and friction between the aggregate and soil cohesion, but in the rigid pavement stability is derived by the structural strength of the pavement by its slab action. Okay, and also the flexible pavement initial cost is less and the rigid pavement initial cost is also more. The lifespan is for flexible pavement 10 to 20 years, the rigid pavement is 40 years, and also maintenance cost is more for the flexible pavement and the maintenance cost is less for the rigid pavement. Okay, these are all the comparison between the flexible pavement and rigid pavements. Okay, here this slide shows the different components of pavements. The major components of flexible pavement structures include the subgrade, subbase, base courses and surface courses. Okay, each layer has a specific role from the supporting the pavement from the bed to providing the durable surface for traffic. First, here we need to understand the subgrade. The subgrade is a compacted natural soil layer that forms a foundation for all the other pavement layers. Its top surface is known as a formation level. Depending on the terrain, roads are built up in the embankment, cutting or at ground level. Okay, one major road like a national highway, the minimum compacted thickness of subgrade is 500 mm. For rural road with lighter traffic, 300 mm thickness is sufficient. Okay, and then subgrade strength. In the subgrade strength, several tests were tested. The California bearing ratio test is conducted in the lab on compacted soil sample, often soaked to stimulate field condition. The dynamic cone penetration test is used in the field to assess in situ subgrade strength, and the trial compression test measure soil properties like cohesion and internal friction, though it's less commonly used for the subgrade evaluation. Okay, the next one is a subbase and a drainage layer. Here the subbase lies directly above the subgrade and supports the base courses. It helps in distributing loads and also serve as a effective drainage layer. Crushed stone aggregate with high permeability are used here to drain water quickly. Okay, this layer extends across the entire road formation width to ensure the proper water outflow in the road terrains. In the next one is a base course. Here the base course is a key structural layer of the flexible pavement and lies just below the surface courses. According to the Moore, the aggregate impact value should be less than 30% and the loss than operation value must be 40%, ensure durability and strength. The last one is the surface courses. In the surface courses is a topmost layer of the pavement and provide a smooth, durable, impervious riding surface, and also it is directly exposed to traffic and environmental condition, so it must resist wear, deformation and water infiltration. Here bituminous layers such as surface dressing, 20 mm pre-mixed carpet with seal coat and 20 mm mixed seal surface are commonly used in India for wearing courses. Okay, thank you all.